Viewers, I am Professor S. Jeevan Chandra, Department of Microbiology, Chaitanya Deemed University. Today, I would like to explain spectroscopy, its application in biological field. First of all, light is a radiant source of energy. Energy is having a different kind of activity that is going to change molecular aspects of a particular matter. Light has two properties, particulate property and wave property. It was perfectly explained by Einstein. He speculated that energy of a particular light is equivalent to mass of particulate character and light wave number c wavelength, light velocity is square of the product. Lights are of two kinds, polychromatic light and monochromatic light. Monochromatic light is a single colored light, but polychromatic light is the mixture of all colors. Whatever the light we are seeing through a white color light is a polychromatic light, and when you pass this light through a prism, you will obtain different spectra, that is called monochromatic polychromatic system splitters. So coming to spectroscopy, what do you mean by spectroscopy? Spectroscopy is nothing but interaction of the molecules or matter with the light. The study of interaction of electronic magnetic radiation with matter is known as spectroscopy. In spectroscopy, what happened? The molecule or the matter will behave differently with the light. Light has one wave nature and electric magnetic nature. This representation is called spectrum. Spectrum is nothing but a representation of light according to its wave number and electric configuration, that is called spectrum. Coming to spectroscopy, when matter or a sample will observe the light and that results in the formation of different aspects. What are they? The molecules either behaves differently and absorbs some part of light called absorption spectra. The absorption will be 100%, that is called opaque molecule. Black body will consumes all the light. Opaque body won't allow light. Next, water and air are the transparent media. The observance of light and transmittance is equivalent to each other. There is no observance, that is called 100% transmission. That solution, that matter is called transparent medium. Some amount of light will be observed, some amount of will be emitted or allowed for emission, that is called translucent medium. For example, sunglasses, some amount will be light will be observed, we can look through the sunglasses, and based on this property there are two kinds of events. What are they? Absorption of the light or emission of the light. Coming to emission, when the light is strikes on a particular matter, now it is going to absorb some portion, and now they are exciting from ground state to excited state. When light is allowed from ground state to excited state, the electronic configuration is going to be changed. The violet color is changed into yellow color. This represents the excitation. When the excited molecule will come back to original ground state, again the whatever the energy they observed is emitted in the form of wave, that is called emission. The excited state molecule will emit the light. So emission of the light is depends upon the two principles of Aufbau principles. The light wave number and energy are perpendicular to each other. If wave number is more, energy is less. Where energy is less, wave number is more. They are going to change the molecular configuration of the atoms. All atoms or molecules are made up of atoms. Atoms are made up of electrons and neutrons and positrons with the nucleus. Now they are surrounding the matter and rotating around the cell, that will going to configure for the excitation phenomenon. As we know that the interaction, the measurement of the spectra produced by the matter when it is interacting with the radiation is called spectroscopy. Simply, spectroscopy is the principle involved in measurement of spectra interacting with the matter. If you are representing the results in the electromagnetic radiation, it will also known as spectroscopy. Generally, the spectroscopy used to determine the radiation of a particular system, light utilized, and the interaction between the radiation with the matter. When you represent a function of wavelength, it is called spectroscopy. So, spectroscopy is defined as any type of measurement. What type of measurement? A qualitative or quantitative measurement as a function of wavelength or frequency of a particular light. So, spectroscopy experiment will give you electromagnetic radiation of a specific wavelength which passes through a source of sample, and the sample containing compounds of interest will interacting with the light, that results in the either absorption or emission of the light. This absorption of the sample corresponding to light source, and emission will be corresponding to its nature of the molecules. Now both are represented in the difference in the wavelength of the source and emitted spectra. Based on this aspect, we have two spectroscopies: absorption spectroscopy and emission spectroscopy. The sample compounds are excited by electronic radiation provided by the light. The molecules absorb the energy from electromagnetic radiation that become excited and jumping from low electronic configuration to high energy excited state. So, the difference between the energy transition change is called delta E, that will give you the amount of energy that a molecule will absorb the system. This is also known as absorption maxima. Absorption lambda maxima is a amount of wavelength and wave number radiant energy absorbed by the molecule, then they go to excited state. Within the excited state, several properties have been here we the excited molecular differences will be in different configuration that will corresponding to particular molecule and its behavior. So, where the spectroscopy can be applied? What is the spectroscopy used for? Generally, it is used in analysis of physical nature of the molecule and chemical nature of the molecule to determine the molecular, physical, chemical. The physico-chemical aspects can be determined, and we can also quantify the molecule and structural component of the sample of a particular representation. This will represent the molecular nature, atom nature of the molecule, that speaks about either absorption, emission of a particular electromagnetic radiation. So, it is depends upon a characteristic molecule present in that sample. So, thereby this will be used to characterize the molecular properties, we can deduce the structure, we can analyze the composition of the sample. So, now it is called, it can be used for quantification as well as a So, these spectroscopy applications include determination of atomic structure and molecular nature, and determination of metabolic components of present in the particular muscle or any biological material, and we can also observe the dissolved oxygen present in the freshwater or marine ecosystem or in a body. So, it can be used to account for the spectral emissions present in a particular galaxies. So, galaxies will be emit the light, we can also capture them and we can study them, and this will be used to structural alterings present in a particular drug can be attributed, and it will be perfectly utilized for the characterization of proteins. And so these all are there in the space exploration, because in the space we can determine the composition of the atmosphere, materials present in the earth crust of a particular planet, and what are the life molecules. So like that we can also explore the space we can capture the gamma radiation, alpha radiation and beta radiation. So this will be contributing for respiration analysis in the hospital. Not only the space exploration, it will be also applicable in hospital for gas analysis in the patients. We can also analyze the diseased patients and healthy patients. The gas differences can be attributed for the disease condition of the patients. So that is the application of the spectroscopy. Thank you one and all for your patience.